Hello. In the last video, we have seen the process aspect of data science. But taking the systems thinking view, we said there is one more component, of course, the implementation side of it using programming. In this video, we will look at what are the different choices a data scientist has in terms of tools to use for programming. And I have tried to classify these tools into different buckets. One bucket would be to start for those who don't necessarily know programming, and it will move on to more complex buckets that require more programming experience. To start off, there are some no-code environments. These environments advertise themselves as tools that people with limited or no programming, they can access them and actually find some interesting insights from data. Examples include H2O.ai, IBM Watson, Amazon Lex, Data Robot. As you can see, these are all commercial offerings, and these companies spend quite some amount of engineering effort in building easy to use interfaces and hiding away the complexity so that a large set of people can do data science. The next set of tools includes spreadsheets and BI tools. BI stands for business intelligence. Common among them are tools like Microsoft Excel, Power BI, Google Sheets, and Tableau. Now, as you can imagine, these are known to a large number of people. For instance, Microsoft Excel is something a large number of people still use for number crunching. It provides ability to graphically see the data, do plotting, write formula, and so on. And importantly, for the more expert users, it also provides ability to write functions and do more complex operations like pivoting of data. So you'll still find a large number of industries, let's say in the financial domain, who still do most of their data science in Excel. Similarly, Power BI, in fact, BI business intelligence is about creating good dashboards that can summarily show what is happening in data. For instance, let us say you are Swiggy and you are a company that is delivering food in multiple cities. You would like to have a dashboard that shows how many deliveries are being made in which city, how many bad customer feedback is coming dependent on the city or even region, and so on. And tools like Power BI are good in handling that. They can work with streaming data and show you these dashboards updated as data comes in. Similarly, you have Google Sheets, which is a equivalent of Microsoft Excel, but on the cloud. And we have a tool like Tableau, which specializes on visualization in drawing more complex and interesting visual summaries of data and thereby communicating on it more effectively. So clearly, this section is for people who know some amount of coding, who understand statistics, but still would like to use graphical user interfaces. The third class is, of course, using programming languages, and there are many choices here, starting from Weka, SAS, R, Python, MATLAB, Mathematica, and so on. Now, these are different tools that have come at different times. Weka was one of the first ones to come. It in fact came from a university as a tool to do data science. Then we had SAS as an industry product for doing data science on enterprise grade data. Then we had R, which is still very popular as a way to do data science. It provided an interface for data science in particular with lots of visualizations. Then we have Python, which we will talk a lot more about. We have MATLAB, which it stands for matrix laboratory, essential idea being how do I manipulate matrices and high dimensional data. Then we have Mathematica, which brought in some good insights of combining data sources with functions. I think the essential idea of Mathematica is to go towards intelligent machines which have access to a lot of data and a lot of functional primitives. For instance, Mathematica provides access to data like stock market data, biological data, data from the space, and so on and so forth. So these are, of course, different choices of languages. A person using them would be expected to know syntax of this language, write complex software, and so on. But again, within them, there is quite a bit of spread, and we would see why some of them are more useful at our course. Finally, you have high performance stacks where you need to ensure that the software you write needs to run at a high performance in a highly distributed way. Good examples of this include Hadoop and Spark, where you can ensure that you can work on big data which has high volume and high velocity and still get good performance because you have parallelized it across many machines. This is again something that data engineers do and is probably closer to deployment and not as relevant for us in this course. So where are we in this course? We'll be focusing on programming languages as the tool, and in particular we'll be looking at the Python programming language. In the next video, we'll discuss why Python is a good choice and also go into a bit of details about what libraries we'll use. Thank you.